10th of February 2009. Floating in low Earth orbit, an idle Russian satellite collides with a commercial US-operated one at a speed of 11.7 kilometers per second, so 40 times the speed of sound. This marks the first instance of a collision happening at such an extremely high speed. In the weeks following the incident, it is estimated that the crash creates 1,000 pieces of debris larger than 10 centimeters. The pieces were still observable in orbital decay around Earth even 2 years after the collision and must have slowly burned down into the Earth's atmosphere by now. More than a decade later, with around 7,000 active satellites in orbit, the possibilities of such incidents are more and more real. But could humanity turn the space trash into a practical resource?
I think we should consider space as it is, a common good, and therefore it becomes obviously up to everyone and all the countries to manage this.
This was Sabrina Andiappane from Clearspace, and here's Bernd Weiss from Lulea University of Technology.
In order to tackle the grand issues we have and the grand challenges in our societies, like climate change, like resource depletion, we need to look into how can we innovate into the future on a more sustainable way.
I'm Hanna Siemaszko, and you're listening to Resourceful, a podcast which explores the exciting new opportunities of space resources. Resourceful is produced by Esric in collaboration with Silax.
We have surrounded our planet Earth with spacecraft that make our daily lives easier to navigate, help us tackle the impact of climate change, as well as answer vital scientific questions. Today we are launching 10 times more than we did 10 years ago, and even if there is a lot of space in space, it is all becoming a bit cluttered. Right now, we are only talking about satellites and space stations, but with more and more missions to the moon underway, estimated at 400 by 2030, we will become increasingly challenged as a society to rethink our footprint in space and switch to circular mindset. On Earth, electronic waste is foreseen to reach 75 million tons by 2030, but what about the trash that is currently floating above our heads? We have asked Sabrina Andiappane from Clearspace and Bernd Weiss from Lulea University of Technology to clear the air for us and explain what kind of solutions they envision for a circular future of space.
You already start seeing, I would say, the premises of a circular economy and reusing things is, first of all, a satellite works really well and it lasts a very long time, especially in the geostationary orbits. So first, seeing that you could do a life extension on them, and then you could also foresee in the future, if the satellites are prepared to do more advanced operations, you could refuel them, you could repair them, change payloads, and maybe in the future take them to recycling and reuse the parts of it.
Similarly to the approach we take nowadays in cities and regions, the application of circular economy has great potential to rethink how we produce, develop technology, and applications.
And one of the concepts that promises very good results is the circular economy, because in the end, circular economy changes the way how we produce, but also how we use products. And that's, of course, for a systemic change, very important. And that's where the connect between circular economy, that it's like a subgroup of sustainability, but it's promising if a company focuses on developing circular economy and products for the circular economy, that it's becoming sustainable.
A lot of noble keywords there, Bernd, but how are things put into practice? In a recent white paper published after the Clean Space Industry Days in 2023, ESA has proposed a concrete list of actions. These specific steps would enable humanity to do better with regard to protecting Earth's environment, reducing the exploitation of materials, as well as containing the number of launches, returns, and handling end-of-life equipment from future lunar and Mars missions.
We're planning to have more and more activities in space and also human activities in the low Earth orbit. We already have, obviously, the ISS. We hear about it, the fact that it gets hit by small pieces of debris all the time, that it needs to move several times as well. But if you're going to have more and more stations, more human activities, you can imagine that these kind of things, if it happens on a station, like the movie Gravity, I just watched it recently, it can get really, really bad. We know it's a problem. Space is big, obviously, but the more objects you have, I think it just increases the probability of having more collisions. We need to intervene before satellites become debris. And that's why, all the thing about in-orbit servicing, life extension, refueling, repairing, and all this will come in handy. To enable more and more advanced operations on satellites, they need to be prepared. We were talking about eco-design, but before going really up to eco-design, you can just, first of all, have your satellites ready with the right interfaces, the right handles to make sure you could capture it more easily, and these kind of things. This needs to come out now, and I think we do realize there is a need, but it's not enough endorsed. More can be done.
The next level would be really utilizing the resources on the moon. And from there, of course, possibilities are infinite. There are like projects looking into creating solar panels on the moon, basically. There are other projects building housing on the moon, like really using regolith on the moon to build habitats. And we have the future looking into how can we utilize maybe other resources in space. So I'm a strong believer that in the end, we will end up having these resource use. And then, of course, we also have the satellites, the man-made debris in space that we can collect and reuse once we have the systems. So space resources will play a big role, but a lot of technology is needed.
The in-situ utilization of space resources is one of the key enablers for a sustained and sustainable next step in humanity's desire for continued and expanded space exploration. Simultaneously, until we manage to establish a more permanent presence on other celestial bodies and are able to develop the technology for in-space manufacturing using the resources available on-site, we have a chance to develop a system to make the most of what we already have floating in space. Sabrina can tell us more about how Clearspace plans to tackle this first step.
Reusing for me is mostly looking at it from a big object point of view. You're going to use the same object for something else, for another application. And for me, recycling is mostly repurposing maybe elements of an object to create another object and for another application. So we are a bit further away from that. So I would say the first step, for instance, for reusing, it would be something like life extension. But from my point of view, I think in the future, I know a lot of people, especially in Luxembourg, are looking at things related to resources, would be to maybe have like a factory in space and to have, the satellites brought to them. And then, you can just, why not imagine a factory there that's going to dismantle the satellites and reuse and these kind of things.
Grand challenge that we want to tackle and we want to collect, or companies want to collect the space debris and reuse and recycle the materials, basically melt it down. But there are so many challenges we need to address first about separation of the materials. We need to know the quality of the materials and how do the features of a material in space, and especially when you melt it down in space and we want to reuse in additive manufacturing in space, how these the features change. I believe the next step will be really refueling. The next level will be then upgrading and updating satellites, and then probably using solar panels and other components for the next generation of satellite.
To learn more about refueling in space, listen to our previous episode and find out more about the variety of propellants that are out there. Coming back to Bernd and reusing satellite parts in space.
Everything that we want to reuse, that we can reuse, like the structure of a satellite and upgrading a satellite with other parts. The components in the satellite, think about the solar panels. If we can take them from one satellite to another, that's reusing of a satellite panel. By the end of the life, if the solar panel is not functional anymore, or the degradation of the module is too big that it doesn't make sense anymore to reuse, we need to separate the materials in order to recycle them. That means that we go away from the product that it was, from the system, from the component, and we take the materials itself and reuse or recycle the materials into another purpose.
There is an old saying that one man's trash is another one's treasure? What if we looked into reusing space debris, that is, small pieces of satellites or launchers flying around Earth? Though debris is typically viewed as a hazard, it may also hold potential as a valuable resource in space exploration. For instance, metals and other materials from defunct satellites or spent rocket stages could be salvaged and recycled for construction and space habitats, or as raw materials for manufacturing spacecraft components. We have to bear in mind, however, how space exploration started.
I think one thing we should not forget is space was not made initially to be sustainable at all. So we cannot just also decide that things are going to change very quickly. And so everything you send, is metal in the end. But however, as you were saying, these is resources that can be reused as we are doing currently right now on Earth. So we'll take time, but I'm sure we'll get there for space as well. Space junk can be actually small pieces of satellites or small pieces of launchers. So it can go up to being something of a few millimeters, something being the spacecraft fully itself. So that's what we call space junk. Usually in the space terminology is also what we call like space debris. So to measure them, actually, there are several ways. So currently what we do is we actually do it from Earth. We have telescopes and radars and all these kind of possible tools that we have on Earth to measure what is actually in space. So that's a first way to do that. One example I can give is that in the low Earth orbit, with the tools we have on Earth, like telescopes and radars, you can measure an object that is up to 10 centimeter. There's obviously a couple of errors and things that goes with it, but it gives you an idea and you're aware of what is in space. On top of that, actually, every time you send a satellite or an object in space, you license it. So you know the numbers of satellites that were sent so far. And you kind of also know the ones that are still working. So that's why they always say that there is more than 6,000 satellites. I think it's close to 7,000. Actually, the numbers varies depending on the databases. And only 40% of them are actually functional.
It really seems that we are slowly reaching a moment described in the 70s by a NASA scientist, Donald J. Kessler. We stand a high chance to have such a high density of objects in the low Earth orbit that collisions between them could cause a cascade and further increase the likelihood of collisions.
The Kessler effect is that you have first one collision, then you have one, it sets up another and another and another, and the orbit becomes completely jammed and you have nothing left. It's like chaos. So that's, I think, the worst scenario, and it's the catastrophic one, but it's something that could become real. So that's, I would say, in terms of danger, the extreme one.
It's a very real concept, so it's possible. But I really hope that we will be able to tackle the grand challenges before it really comes to this devastating effect that Kessler predicted.
Contrary to more static beginnings, the future scenario of our presence in space is also about the capability to move.
The thing is, we're planning more and more vehicles that are going to be moving from one spot to another. The vehicle we are developing, a servicer vehicle, is an autonomous robotic vehicle that can go to one satellite to do rendezvous and capture it. So it's not going to be any more a static environment for them. They're going to be moving. So at the moment, you can still navigate, I would say, in space. But you can imagine if there are more and more elements, it's like getting a bit stuck in traffic jam. So the satellites, I would say, at the moment are steered from the ground and they have everything on board. But we need to also implement more and more autonomy.
Just like on Earth, in space we are faced with an unsurmountable amount of junk or debris. Developing the necessary technology for Earth applications has taken us a long time. We can't expect space technology to be any different. Then there's also the fact that testing space solutions is costly and requires the engineers to work in emulated environments.
First of all, a satellite, when it's sent to space, is supposed to be having everything already on board, like the propellant and everything, to make sure it's going to deorbit. So whether this is in low Earth orbit, so this is close to Earth, or geostationary orbit, which is 36,000, your satellite is supposed to have the technology on board to deorbit. So when you're in low Earth orbit, the satellite is supposed to come back into the atmosphere and burn, and this is how you deorbit it. If you're further away, they're actually sent back into a graveyard orbit above the functional orbit of the 36,000 kilometers. So that's how it works. So usually they're supposed to do it themselves. sometimes things obviously do not go as planned. And that's where we actually come in. Companies like we are in Clearspace, we are imagining solutions. If something goes wrong, what do we do? So the first type of mission we are planning is actually fully debris removal. So the first one we are planning is called Clearspace 1. It's going to be launched in 2026. Is we are actually proving the fact that we can completely deorbit an object. And our target at the moment is the last stage of a launcher that's been there for a while now. So we're going to send a super robotic space vehicle with arms that is going to go hug that debris and bring it back to Earth. The first thing to do would be to remove the existing, I would say, big debris, because this is what we imagine to be the most threat at the moment in terms of debris that are in space. But on top of that, you could also foresee some other kind of activities. If for smaller pieces, there's been studies in the past about having like nets or other fancy things, a bit more, I would say, not really crazy, because how do you want to capture small pieces? It's not easy. So there's been a lot of technology that's been tested, but it's not something trivial. And obviously, removing the big ones is much more important at the moment. This is the things you could do in space. And the other part would be to make sure these satellites do not become debris. So it would be to intervene before and plan what we call in-orbit servicing. In-orbit servicing, it will be to intervene on the satellite, perform operations, so it does not become a debris. And the first kind of mission we are planning actually will be in Luxembourg. This is what we started designing. It's called Encore. And the goal of it would be to extend the life of a satellite.
Another interesting approach to space exploration is being sustainable by default. This means designing systems, processes, and products with sustainability as a fundamental principle from the outset. It does not require conscious effort or additional resources, as it is already embedded in the design and the decision-making process. On his side, Bernd is currently developing concepts to implement circular material flows in the space industry. Let's hear more about that.
We are working on a roadmap, on a framework together with partners that focuses really on shifting from innovation to sustainable innovation, the point what we already were talking about. And then very important is we need to start designing spacecraft for the space reuse. The concept we put out with considering the space environment and all these implications surrounding the space environment are crucial for the circular economy in order to work in space. And then, of course, what also should be on the agenda of every space company is to proactively advocate for policy, because it's known from the history, policy in the right way is a massive driver for innovation. And where there are policies and where there are new regulation, typically there are also funding mechanisms for companies, early adopters and so forth. So promoting actively to implement policy for circularity, for sustainability in space. The vision what we are following up with is like looking into a spacecraft of the future. How can we design a spacecraft that it's reusable, maybe even repurposing in space? So it can look like we are designing a satellite for one mission for the next 3, 4, 5 years. We launch it, and after 3, 4 years, we upgrade it to a total different mission. We are building the satellite, the whole structure in a modular way. So we basically only launch the new mission component, the new mission module. We add it on to the satellite and take the other mission module away. And this old mission module, we can then either pick apart, use and reuse the components and the parts that are still working, or we separate the materials, try to melt them down to be feedstock for additive manufacturing for other purposes then. And if you think about the future, it might be possible that we can go to the moon, use the resources from the moon or even from asteroids to even build bigger structures, to use then the module and the components from an old satellite and add them into a much bigger structure that it's basically built from materials out of space.
The space industry is a test bed for innovation, but can it be coupled with sustainability? Bernd says that we need to shift from technological, profit-only approach to sustainable innovation that directly considers the implications.
What are the implications and what are the results, basically, if we innovate a product that we consider sustainability impact and the environmental impact or the societal impact of a product right from the beginning of designing and working on innovations. There's a little paradox. We need more innovation, but we also know that innovation was in the past the driver for pollution. And because with innovating, we can make products better, faster, and we can make mass customization of products, which leads to more products. We can optimize production on Earth, like clothing and fashion is the best example, because we are innovating in fabrics and the machines, we can produce more. So instead of making it more sustainable, it made it actually worse.
The moment big industry actors play a more active role in it, standardizing the approach becomes indispensable, and Europe can be at the forefront of developments.
That actually comes back to standards and regulations, and that's why we usually need our governments, our institutions, and this is something that Europe is playing a big role on it. They're planning a European space law. They're, I think, really going to help actually this become real. But there's so many players, so many stakeholders, and now this is also a business that is also commercial. So I don't have a clear or an exact answer for you. It's something maybe that could be asked to some of our decision makers.
Dreaming further into space, the red planet Mars seems to be the next pin on humanity's bucket list. It is one of the only other environments in our solar system able to contain life, and has therefore immense potential to teach us more about our past and future. It is a giant step indeed, and long-term planning is of essence. It is perhaps our chance to do so in a sustainable manner.
How do we go to Mars? We need to be circular in order to get to Mars. We cannot just shoot something up and then we just get rid of it, and we cannot just bring everything. And so we need to be able to reuse parts, to repair parts, to upgrade parts. The same is for food. We need to look into circularity as a concept in order to be able even to go to Mars. So I would pretty much hope that we can figure out to build structures, and there are really good concepts happening already, even with 3D printing on ISS in demos, that are able to bring us to the moon and maybe even further to Mars later.
Be part of the conversation. If you enjoyed the episode, share it with your friends and subscribe to our channel. If you want to find out more, follow us on social media and join our annual Space Resources Week conference. Until the next episode, stay curious. This series is brought to you by the European Space Resources Innovation Centre, ESRIC, supported by the Luxembourg National Research Fund, FNR. It is produced in collaboration with Silex.